Chapter 7, Lesson 6 of Advanced Algebra, and we want to look at how do we determine range values. Now, determining the range values is a bit more difficult than determining domain values. You remember with domain values we had two situations that we needed to look for, a variable in the denominator or a variable in a radicand, or as a part of a radicand, and then we simply set those denominators not equal to 0 or those radicand expressions greater than or equal to 0, solve the expression algebraically, and we were able to determine what the domain was. The range values, we don't have any algebraic way to do that, and so we need to think about what the function looks like, and and that can help us determine what the range is. Now the range, you remember, are the y values that are being produced by the substituting in of those x values, or those domain values. And if we think about what the function is, or if we understand a little bit of what the graph of the function looks like, we can maybe determine what the range is by using our knowledge of the function. For instance, if we have an even index, we know that the radicands are going to be positive, and we also know, therefore, that the roots will be positive as well. We're looking at the principal roots here. So we can use that knowledge to say then that the range values of the y values are all going to be positive. The second way to do that, and probably the easier way for us to do it, and what we'll probably do most often, is we'll just go ahead and graph the function. We'll use our calculators, we'll graph the function, and then we'll determine what the range value is by inspection. The range value are all the y values, so what we're going to do is look for the highest y value and the lowest y value used, and that's going to be our range. And so that's what we're going to be looking for when we're looking at a graph. So we'll simply graph the function, look at the highest y value and the lowest y value. The range then are all the numbers in between those two values, and then we'll use set notation to express that just like we did with the domain. So let's take a look at a few examples, and maybe this can help us do this. So do this way. So here's the graph of the function x squared. Alright, so what we're looking for is the highest y value. So as I look at the graph, this graph goes up to right about here. This is its highest point. So right here would be the highest y value, so that's a y value of 2. Now this function goes down forever, so we're looking at all y values that are less than this value of 2. So our range would be then all real numbers such that, or as long as, y is less than or equal to the number 2. So for our second example here, again, we're looking at the y values. So we'll notice that right here is the lowest point of the graph. It doesn't go below this point, so that's a y value of 0. And then this function gradually grows and increases, and it keeps going up. So our range is going to be all y values then that are greater than 0. So all real numbers such that, or as long as y is greater than or equal to 0. Here's an example of a linear function. A linear function, you'll notice that the y values, this line goes down forever and it goes up forever. So there are no y values that aren't used. So this would have a range of all real numbers. There are no restrictions, or there are no y values that will not be used in this function. Okay, so I think that's pretty easy. We're just going to need to graph these functions in order to, I'm looking to see if there's any more that are challenging for us. No, they're all about the same. So I guess we'll just go ahead and do this one, seeing how I have it right here. So what would be the range of this? Well, again, we're looking for the lowest y value. It goes down right here. So again, it starts at 0. And then the y values, they go up and up, they never stop. So our range here would be all y values that are as long as they're greater than or equal to 0. So all real numbers greater than or equal to 0. Okay, so range, again, a little bit more difficult algebraically. We can either use our knowledge of the functions, if we know what the function looks like from the equation, we can get the range that way, or we can simply graph it on our calculator and look at the function and determine the range by inspection.